Good morning, everyone. Today we are going to look at percentage yield and percentage purity. And this is very important for matric because we're going to use that, especially with acids and bases, a lot. Now, don't confuse percentage yield and percentage purity. They're both percentages. So you're going to divide the actual value by the possible value times 100. Say, for instance, you had 8 out of 15 for a test. Then 8 at the top is your actual value, and at the bottom, that 15, that was the possible value, right? So it's actual divided by possible times 100. Now let's see how we are going to apply this to percentage purity and percentage yield. Now, if you look at percentage yield, that one at the bottom, then it means you had a reaction A plus B that reacts to give you C. C is my product. Here we have to work out, if you do this in the laboratory or wherever, what is your real percentage yield? How much did you get out of how much you were supposed to get? The possible yield you are going to determine with a mole calculation. So here we're going to take the mass of A that we're using, convert that to moles, get the number of moles of C, and then work out what was the possible mass. So I'm going to do my mole calculation, and my mole calculation is to determine what is possible. So here our mole calculation is to work out that theoretical yield at the bottom. So we're doing a mole calculation, and you're definitely going from left to right because you want to work out the possible yield. Then let's look at percentage purity. Now with percentage purity, remember, they are giving you something that is not pure. Say for instance 20 grams, and they tell you it is magnesium, but they also tell you it is impure. And if it is impure, it means there's some magnesium in there, but there's also a lot of other things. Let's say junk, right? So we've got some magnesium, we've got some other things. Now here, the whole sample could have been pure. So the whole sample is going to be my bottom value. The possible mass was the whole sample. So remember that 20 grams, we're only going to use that down there. Don't use that in a mole calculation because there's definitely not 20 grams of magnesium there. It's going to be something less. So how do I determine that mass of magnesium? Now for that, we're going to do a reaction. We know that magnesium will react with hydrochloric acid in a reaction to give you magnesium chloride and also hydrogen gas. And if you add that whole sample to an excess of the acid, it means all the magnesium in there is going to react and produce hydrogen gas. And then we can measure the volume. So we have the volume that is produced, and from that we can work back. We can get the number of moles that were produced. That is going to give me the number of moles of magnesium that have reacted, and that will tell me what mass of magnesium reacted. So this time I'm working from the right to the left. I'm working back to determine the number of moles of magnesium and the mass of magnesium that reacted, because that is the actual mass of that compound. So this time we worked from the right to the left. We worked back because we wanted to know how much magnesium was there in that sample, right? The real value of magnesium. So remember, with this one, you are working out the top value with the mole calculation. So that is the difference between the two. So for percentage yield, you are definitely going to work from left to right in our equation to determine the possible yield, and that is the value at the bottom in our equation. If you're working with percentage purity, you are going to do an equation and you're going to work back to work out how much reacted, because all the magnesium reacted, so that's going to give us the mass of the actual compound. So that's the one at the top. Now is the time for you to pause this video to see if you can do the calculations. Come back when you've finished them all. Right, I hope everyone is finished. In question 1, they gave us the Haber reaction where they're using nitrogen and hydrogen to produce ammonia, and they tell you 24 grams of hydrogen reacts and it produces 200 grams. Now, it produced 200. That is not to say that it was supposed to produce. It really produced 200 grams. So that is my actual yield, right? I don't know what 42 grams was supposed to give you, but the actual yield was 200. The easiest way to think about it is think about the percentage yield equation first. That 200 grams of ammonia that they produced is going to be the actual yield. So that's the value at the top. Now we need to do a mole calculation to determine the value at the bottom. I'm going to use my equation. I'm going to use the mass of 42 grams that they put in, and I'm going to work out what is possible. So here I'm going to start by converting that mass to moles. Then a quick conversion from H2 to NH3. They're in the ratio 3 to 2, and that tells you that there's 14 moles of NH3 produced. And then I'm going to convert that to mass. This is now the possible yield, right? I worked out what is possible. On paper, it was possible to get 238 grams. Now I put the 238 grams into my percentage yield equation, and that tells me that the percentage yield is going to be 84,03. In question 2, they give us 100 grams of silver nitrate reacts with an excess of magnesium chloride. They give you percentage yield. So the mass of precipitate that has formed that they're asking you is your actual yield. So let's start with the equation and think about it. They gave you the percentage yield and they're asking you for the actual yield. So this time we need to do a mole calculation to determine that possible yield. So I'm starting with 100 grams that they put in, and I want to work out the possible yield. So first let's convert that 100 grams to a mole. Now we have the moles of silver nitrate. Precipitate, that means I'm looking for my solid, right? And that's going to be moles as well. So now I have a mole to mole. I need a ratio, and they're in the ratio 2 to 2 or 1 to 1. So the same number of moles that I put in is going to be produced on the other side. And then I need to convert that to mass. So now I've worked out what was the possible yield, right? I could have produced 84,38. So that's going to go in the bottom in my equation. And then it gives you an actual yield of 67,50 grams. I hope most of you got that right. Now in number 3, they tell you 95 grams of unpure magnesium. So immediately, if it's unpure, you have to be very careful. Don't use that mass in a mole calculation because some of that 95 is actually not magnesium, right? And then they tell you that 150 grams of magnesium oxide is produced. Now the first problem here is they don't give you an equation. Let's just start with the percentage purity equation. They just give you that 95, and that is the sample. So that will be going in at the bottom. We need to do a reaction to determine how much was really magnesium. And this time they're going to burn this and make magnesium oxide. So we are going to work back from that magnesium oxide that is produced to work out how much magnesium was in that sample. So we're starting off with the produced magnesium oxide and work out the number of moles. Then we will have to convert back to magnesium. So the ratio is 2 to 2, and that tells me how much magnesium reacted in moles. And then I'm just going to convert to mass. So now we've worked back. Remember, with percentage purity, I'm always going to work back. And that tells me how much magnesium was really in that sample. So that was A, just the mass of magnesium. And then for number B, the percentage purity, we're going to put it in there. And 90 divided by 95 times 100 is going to give you 94,74. So that was question 3. In question 4, they tell us 20 grams of contaminated sample. Now remember, don't work with the sample 20 grams in a mole calculation. Some of that is not nickel. And they tell us if the sample is 70% pure. Now here they give us percentage purity. So it is going to be a question of starting back from that percentage purity. They give us the purity and they also give us the sample. That is going to tell me the mass of nickel in there. So now we're going to work from that mass, and they ask us to determine the volume of hydrogen gas that can be produced. Now the problem here is you have to write your own equation. You're starting with nickel and they react that with hydrochloric acid, and then that produces hydrogen gas. Now you need to be able to write this equation. You need to know nickel with hydrochloric acid is going to give you nickel chloride. Remember, the nickel can become 2+, so that will bond to the chloride to give you nickel chloride, NiCl2. And then if it's an acid and a metal, then you should have hydrogen gas as your extra product. And now they're asking us what volume can be produced. Now you're not working with the 20 grams, you're working with the 14 grams. And now it's easy. First thing, convert that 14 grams to moles. Then go from nickel to hydrogen gas and then convert to volume. I hope you got that right. In the next video, we're going to look at percentage composition and also empirical formulas.